Hello and welcome to our quick tutorial, which is just following up on the class that we had on Wednesday about raycasting. So what we wanted as a result was something like this. So I'm raycasting here from the top of my character. He's going to collide with my crate here. He's going to have some collision detection, and I can walk and then push, and then I'll walk. I've left this quite long, and then you can see I'm pushing, I'm walking, and I'm pushing. I'm idling, pushing, pushing, walking. Yeah, I had a moment of push there, but for the most part I'm walking, and then I'm going to push. Walk back this way, and push. So how do I get that to work? What's going on there? What are the keys to success? The first one is we don't necessarily have to do this. There's other ways to do it, but just one small thing. So when we raycast from the character, the ray comes from the origin of the character. Now, the origin of this character is actually at the base. I've in code told it to raycast from above, because sometimes when you raycast from the feet, you get collision errors here. So I'm raycasting from up here, but I'm ignoring this raycast, this collision box here. So how did I do that? Well, if I take my crate here, it says layer default. If I look at my player, it says layer ignore raycast. So Unity has thought of our problem and preempted it and created a layer that doesn't acknowledge raycasts. So this character here has just been shifted to a layer that its collision box will not be detected. Everything else is just on the default layer. So that's one way to get rid of that collision problem. That's only the first, though, of our problems in this sort of task that I set you. The main problem is about, it's an interesting one, it's an interesting exercise. It's about multiple inputs being true at the same time. Let's just have a think about that. So in our original movement script we had, if we go over here and look at it, and look at how I've changed it. So we had this input here, very simple input. If I press the key D, then change the animator to walk. So obviously we have an additional piece of code here. And this was the same. If I press the A key, play the animation, walk. Now the problem with that is, further down here we have our raycast, and we're going to raycast and say if I hit, this is this is not necessary, it'll work without it, but it's, I believe, more, you can talk to Ross about that, it's more correct to put this in. So if the raycast is not null, so if it's not equal to nothing, and the thing that it's hitting has the tag null. And if we flick back in here, we'll see our crates have the tag null. Then pushing is true. Now what's pushing? Pushing is a boolean. I've declared it up here, variable boolean false. So if I'm not hitting nothing, and the thing I am hitting has the tag null, then pushing is true, and then else pushing is false. So let's look up here. So you can see I've got a duplicate input. So I have to say, if I press the key and it's false, press walk. If I press the key and it's false, press walk. If I press the key and it's true, play the push animation. And why is that? Well, that's because, in a very simplistic way, when I play the game, in terms of what's true and what's false, at this moment here, if I select on my character, my boolean called pushing is true. If I play here now it's false. So while I'm pressing the key is pressed, and the input from the key is true. So if we don't add this in here, we'll have two contradictory inputs. So we'll be saying this is true, so change this to 1. And the raycast is true, so set it to 2. So both of these things can't be true at the same time, or at least they can be true at the same time, but we're not giving Unity a clear indication of what we want it to do. So in this instance here, what we've done is to clarify which one takes priority or which one we want to control. We've added in this extra boolean to say if I press the key and the raycast is false, use the play animation or the walk animation. And if if we're inputting with the keyboard and the raycast is true, then play the push animation. And that is how we use raycasts with keyboard input. So it's straightforward enough, but also complex enough. And then I can, of course, reduce the ray length and make this a little bit more better. And this is sort of what we would do in most 2D games. Okay, and finally, just one other little thing I've done here. So when I'm drawing the ray, I'm saying variable ray or variable hit raycast 2D, and then this is the cast. So this is our original position. So I've sent raycast. So raycast from the origin of the sprite plus move it up by 1. So let's just move this up by 0.5. Oh, that's not 0.5. 0.5. There we go. And where it's a multiplication, so 0.5, and we'll save that. And go back in here and press play, and that's where our raycast is coming from. So this little piece of code is handy. I can also go transform that position plus transform that right multiplied by 1, and it would then begin the raycast outside of the collider, negating the need to do this. But that would then that would cause its own problems, because then I want it basically on touch, so I want this to be quite short, so to give us the best possible sort of animations. Very good. Okay, so that's how to complete the exercise that we did in class. A little bit more to it maybe than we would have initially thought. There are other ways to do this, and one or two of your classmates had come up with those ways, so maybe we'll explore them as well. But for now, that is how we combine raycasting and keyboard input to be able to differentiate between different sort of states, whereby we've got our parameter here and our mechanism setup combined with raycast input.